Hi, welcome to part 2 of the Student Society Web Application Project. So in this part, we're going to look at the object-oriented design of this simple application. So this is going to be pretty much our first jab at it. So we'll have two classes. We have student and society. So notice some constraints that I put up here. So each student can belong to only one society, and each society can only have a maximum of 4 members. So this is a one-to-many relationship, so that we need to, eventually when we implement this as a database, there's a few things that we need to add to that database to ensure that we maintain these constraints. So if you look at the attributes of both student and society, they have typical attributes for these two classes. So there's ID, that's the primary key for both. Type integer. There's salutation, full name, student number on the student side, name, type, and chairperson ID on the society side. So salutation and type, we're gonna kind of limit the options available to store. So for example, salutation will be just either Mr. or Miss. For type under society, it will be either uniform or club. So for these two cases, I think in the database we're going to implement it as enumerated type or enum type. And then you have full name on the student side, which obviously will not be unique. But the name on the society side, that will make it unique. All right. And then on the student number side of student, that will be unique. And the chairperson ID can be null, meaning that a society may not have a chairperson yet, or an ID that represents a student that is the chairperson of that society. So there's quite a number of constraints here which I've not written down, but when we get to the database design part, that's where we're mostly going to implement these constraints. So it is best to implement these constraints at the lowest level, so that irregardless of whatever backend we use, the database or the data integrity of our database is maintained. Now on the behavior side, apart from the usual constructor, you have a student here, you have a society here. Now remember, our classes needs to eventually write stuff to the database, so the student and the society probably will need to access the database, initialize PDO objects and connect to the MySQL server and so on. All right, then there's your typical get set type of methods, like get society on the left here, get total members, get members, set chairperson, get chairperson. All right, so there's also an add member and del member. Del member means delete member, where it expects a student ID as a parameter. So obviously with the constraint of no more than 4, add member will need to be able to check whether if adding an additional member is allowed or otherwise, and plus a few other things that it needs to check. All right, so the rest of it, like find all, find one, add, update, delete. Yeah, so it's there in both classes. They pretty much will handle the CRUD, C-R-U-D, on the database side of things. Now, on the first draft of this, I noticed there's a lot of overlaps between the two. So instead of implementing like this, what I'm going to do is I'm going to implement it like this, where I have a model class that will have quite a few common things. That's why student and society inherits from the model class. And if you notice, the model class has all its attributes and behaviors protected, meaning that all of these can only be accessed by student or society and not outside of it. All right, so the idea here of the model, it is basically maintaining a link to the database. So there's a connectDB method where the constructors of student and society will need to call in order to connect to the database, the correct kind of database. And then there's a get many, get one, and exact SQL command. All three takes an SQL string, a string that basically has an SQL statement. And then an array of key value pairs that will represent, that will basically implement parameterized SQL statements. So if you ask me, why do we do parameterized SQL statements? Well, because we want to avoid something called the SQL injection attack. Hopefully you know what that is. All right, so in the revised student society, I've taken out the ID field, the primary key, and eventually the find all, find one, add, update, and delete will just be calling these guys the appropriate methods here in order to do whatever it needs to do. So by having this, I think we've simplified how we're going to implement the database access part. Now, by no means is the only way to do it. There are many other ways of doing it. You could have, say, a helper database class object that these guys can use to do database work. So like I said, there are several ways of doing it. So it's up to you how you want to proceed. But in our example, this is how I've decided to do. All right. So our next part, we're going to look at how we're going to translate all this into a database. See you in the next episode.